Hello, welcome back. So now looking at section 5.4, which is indefinite integral and the net change theorem. You have learned what a definite integral is and how to evaluate that. Now we are looking at we will be defining the indefinite integral, and the way we define it is using the fundamental theorem of calculus. And if you recall, the part 1 of the FTC says that if f is a continuous function on the interval AB, then the area function, which they are denoting by g of x in your book, you can denote it by uppercase A of x if you want, but it's the same thing. So if this is the situation, then the area is given by this integral, the area function, and the condition is that g prime of x, the derivative of the area, is basically the function under which we are finding the area. Now, part C2 of the FTC says if f is continuous on AB, then the definite integral of f of t or dt, or it could be the same thing as a to b f of x dx, that will be equal to uppercase f of b minus uppercase of f a, where what is f? F is an antiderivative of little f. That means f prime is equal to f. So note here, this one and this one, they are kind of same thing. So, but in this second integral, it's definite. We call it a definite integral, and the reason is because we definitely know the area is between A and B. So you like concrete, what is A we know, and where is B we know that. But in the first part here in this equation, you notice that A is not definite and X is not definite. So A can be anywhere, below X and to the left of X, and again X can be anywhere in this interval. So we are not definite about the limits, so we can call it indefinite integral, and we denote it by simply by the integral without the limits. So the indefinite integral looks like integral sign and then fx dx. This is what the basically what do you get here? Now you get f of x plus c. Okay, what are the properties of these indefinite integrals? They are similar to what the properties of the definite integral, these three. So what does this say? That if you have a constant multiplied by a function inside the integral, by the way, the inside of the integral is called integrand. If you're in your integrand, you have a constant multiplied by a function, you can always put the constant in front of the interval and solve the integral. Second property says that if you have two functions being added and you are finding the integral of the sum, then it will be the same as the sum of the integral. So the integral distributes over the sum. Same thing happens with the difference. Now note here, if you have f of x times g of x, this is not equal to f of x dx times f of g of x dx. This is wrong. Okay? This is wrong. They are not equal. There is no such rule. Now also, and integral of quotient Like this doesn't happen in, remember, in the derivatives, you cannot have this situation. If you have a product, it's not the derivative of the first time derivative of the second. There is a product rule there. Now, and for now, we don't have a rule for f into g, but I'll show you in some cases we can actually do something. So this is not going to be integral of f over integral of g. This is what you need to remember. Okay, so here is the integration table, I would say, in table of indefinite integrals. So these are 1, 2, 3, 4, 5, 6, 7, 14 of them. You have to kind of memorize this. Basically, if you know your derivatives, then this is easy to figure out if you forgot anything. Because remember, the integral of dx, which means integral of 1 dx, is x. Why? Because the derivative of this will be 1. So that's how you can check. Now, the antiderivative of x to the n is this quantity. Why? Because if you take the derivative of this one, you will get x to the n. And in the same case, in each case, that's how it is going to be. Okay, so let's look at the examples. So it says find the antiderivative of each. So when you get something like this, you can think of it as a product of two functions. So if you have a product, you cannot do integration. You cannot integrate it in this form. The goal is, the first thing you have to check is the integrand. Does it look like one of the formula in the table table of integration or integrals or table of integrals? You have to look for if your integral fits one in the table of integrals. It doesn't, this function. So we have to think about doing it some other way. So what can we do here? So think algebra. So if you think algebra, then it means we should be able to distribute this x. But before I distribute, I will write the powers on the two x's inside as a number. So I have integral x into this x to the 1/2 and this one x to the 1/3 dx. Now I multiply. Let me use this place. So this is what I have, and now I multiply. So I get x to the 1 plus 1/2. So 3/2 plus x to the, now I have 1 plus 1/3. So I get 4/3. Three halves, and that is 4/3. And then we have dx. So I just wrote the powers, these radicals in terms of powers, and then distributed the x. So this is what you get. And now you can apply one of the properties that this will be equal to, or this gives you can put an arrow or put an equal to sign, goes to integral of x to the 3/2 dx plus integral of x to the 4/3 dx. So now we can integrate. Now this fits. Now these two integrals fit somewhere. Where? Here. So what will I do? So this is equal to x to the 3/2 plus 1 over 3/2 plus 1 plus x to the 4/3 plus 1 over 4/3 plus 1 plus a c, constant of integration, which is going to give me the answer, which is x to the 5 halves over 5 halves. So we get x to the 5 halves over 5 halves plus x to the 7 thirds divided by 7 thirds plus c. And now we just simplify and get our answer. So what is the final answer? It is equal to 2 over 5. So you can write it in different ways, but it will be like 2 over 5 x to the 2 divided by 5 x to the 5 halves plus 3 divided by 7 x to the 7 thirds plus c. So this will be the final answer. Okay, looking at the next problem on the right here. So again, we have x over 5 minus 5 over x. Now, if you take the common denominator and make it one fraction, it might become harder for you to integrate in that form. So let us keep it in this form. So this is can be written as x over 5 dx minus integral of 5 over x dx. But if now we have to think about how to solve it. Now in this case, in the first case, the constant is 1 over 5. So I can say 1 over 5 integral x dx. And on the second one, we have the constant is 5. So 5 integral 1 over x dx. I hope you understand that 5 over x is the same thing as 5 times 1 over x. So now the integral of the first term is x square over 2 minus 5 times. Now what is the integral of 1 over x? Can we apply the rule that we have here, x to the n type? Remember, 1 over x can be written as x to the negative 1. So if you do this, x to the negative 1 plus 1, then in the bottom you have x to the, which means x to the 0 over 0. So what is the issue with that? What is the problem here? Is this a problem? No. What is this equal to? This is going to be just 1. So we get like 1 over 0. So red lights should start flashing there. What? 0 in the bottom? No, no, no way. So this is not correct. This is not how you will do the second integral. Okay? How do you do it actually? If you recall again, you have to remember the derivatives. 1 over x is the derivative of what function? The log function. So our answer will be 5 ln of absolute value of x. Look at the table. Yeah. So now plus c. So that is your answer. Well, we can simplify a little bit over here. We can have x square over 10 or 1 over 10 x square minus 5 ln of absolute value of x plus c. So this will be the final answer. Okay, next one. Again, we can separate, and along the way, if I have to simplify something, I will do that. For example, in this one, a radical expression, so we can change it to power. So minus, so what will be the power? X raised to 3/5. That's how you change the radical. What about this one? Should I write it like pi to the 1/2? Should I do that? This is my question mark. Okay. And plus e to the x. So now the integral of 5 to the x. Again, go to the table. Where is the e to the x is e to the x. We know that. But when you have b to the x, the integral is b to the x over ln of b plus a c. So what is our b? Our b is 5. So we should get for the first one, we should get 5 to the x divided by ln of 5. Okay? So you see now I'm going to directly do the integral. I'm not going to first write it like separated ones. You know that property just holds. Okay, minus. Now what do we do with the second term? Remember we are integrating, so we will increase 1 in the power. So x to the 3/5 plus 1 will give me 8/5, and then divide by this new power. Plus, now what about this one? Okay, let's go to the last one first. So plus e to the x plus c. Then we will clean this second term, and that will give us our answer. But what happens here? Should I say this will become pi to the 3/2 over 3/2? No, that will be wrong. Why? Because remember, pi is a constant. So square root of pi is also a constant. So this will be just a constant. So what is the integral of a constant? If you have c dx, you see you can bring, well, again you can look in the, so we have k dx. This gives you k times x. Why? Because you can write, because 1 dx is x, so you can pull the k out. So this will become k into 1 dx. So this gives you x, so kx. So that's how you look at this table and use the table. But remember, the table will not be given to you in the exam. You have to remember these. So even if I wrote it like pi to the 1/2, actually it will be, if you want to keep it pi to the 1/2, you may, but then there will be an x being multiplied by it. Or you can leave it as square root of. So which will be equal to 5 to the x divided by ln of 5, sorry, minus 5/8 x raised to 8/5 plus, again as I said, the square root of pi x. But when you write it as square root, just make sure the x is not coming inside the square root. Because often students are in a hurry, this is what they do. Pi x. So this will be wrong, because this means x is also under the square root, which is not correct. So pi x plus e to the x plus c. That will be the answer. Okay. Looking at the next one, this says we have a product of functions, product of polynomials basically. So how do we do that? Can we do integral of this times integral of that? No, that is forbidden. There is no such rule. So how do we do this then? What is the only thing that we can do here? We can distribute. Yes, we can distribute. So algebra is going to come into play. So x square times x square is x to the 4th plus x square times 1 is x square. Then minus 2x square is minus 2x squared. Then minus 2 into 1 is 2 dx. Now even if I don't put brackets here around this, at the end when it says dx, it means that this dx is for all of these terms. So again, I'm not going to write them separately. I can directly do the antiderivative. So x to the 4 will become x to the 5th, or x to the 5 divided by 5 plus x square will give you x cube over 3 minus, oh, by the way, we should have first combined these two. Yeah, should have first combined the like terms. Integral x4 minus x squared minus 2 dx, which give me x to the 5 over 5 minus x to the 3 over 3 minus 2 dx. Integral of 2 dx will be 2x, and then plus a c. So this is your answer. Okay. Now, again, there are sometimes expressions which don't fit in your table, in your integration table. So, for example, something like this. You will see there is nothing like this in your table. So, what should you do? We will learn some other techniques. So, it could be that you can apply one of those new techniques. But for now, knowing what you know at this time, what you should do is manipulate this expression or the manipulate this is called the integrand. Remember, manipulate it so that it looks like it becomes familiar. It looks like one of the table, one of the rule in the integration table. So if you recall, sine over cosine is tangent. So I can rewrite this expression inside as sine of x divided by cosine of x times cosine of x, which means I can write it as sine of x over cosine of x times 1 over cosine of x dx. Note here, we can write it like this because there were two cosine x's being multiplied in the denominator. If I had cosine x plus cosine x, I cannot get it to this form. So now we can rewrite it as, first one is tangent x, and the second is 1 over cosine is secant x. Does that sound familiar? If you know your derivatives, you should know this is the derivative of what function. Did you get it? I mean, like, you can always go back, look in the table, but eventually you have to kind of know it. So this is the derivative of the secant x. So the entire derivative of this quantity will be secant x plus c. Next one is then this is something. This looks like a product of secant x and this expression. Now, sorry, I have changed the variable here. So we can have different variables or different. The important thing is that the d of it should have the d of that variable that is in your integrand. I mean, if I put dx here, you cannot integrate it. You cannot write the integral, okay, entire derivative, because this dx is saying that integrate with respect to x. Well, there is no x here. So either there is a typo if you see something in the exam, or so there is something wrong. So keeping it the same way with the theta, what can we do? Since this is a product and we don't know the product rule yet for integration, So what will we do? Distribute. So if you distribute, you get secant theta times secant theta, which is secant square theta, plus secant theta into tangent theta, d theta. Now again, if you separate them, you get secant square theta d theta plus integral of secant theta times tangent theta d theta. Now the first one is secant square is the derivative of tangent. So the entire derivative of secant square will be tangent of theta, and then plus, we all just did that one. This is going to give us secant of theta plus c, and that's your answer. Looking at the next example, what do you think? What should we do? Distribute, right? Because we don't know the product. What do we do with the product here? So we can write it as integral 3 to the t plus 3 to the t times 2 to the t, and then we have dt, which is equal to integral 3 to the t remains as it is, but what happens to the second term? How can we write the second term? Sorry, this term. So if you recall, one of the properties of the exponents is that if you have same power and bases are different and their terms are being multiplied, then the bases get multiplied. So we will get plus 6 raised to the power t, and then dt. So if you distribute integral 3 to the t dt plus integral 6 to the t dt, which is equal to 3 to the t over ln of 3 plus 6 to the t over ln of 6 plus c. Okay, what about the last one here? So can I do this? Sine cancels with sine, x cancels with x, and I'm left with 2dx. Is that correct? No, no way. These are not being multiplied. These are functions. You cannot do this. So then how to simplify it? Well, again, you have to recall your stuff from Calc 1. It's actually trigonometry. So you can write the sine 2x as 2 sine x cosine x whole divided by sine x dx, which is going to now sine x will cancel with sine x. So this will cancel with this, and we are left with 2, which I can put outside the integral, and inside we have cosine x dx. Now what is the antiderivative of cosine x? It's sine, we know, but will it be positive sine x or negative sine x? This is something you have to remember, because sometimes students make a mistake here. So 2 just says antiderivative of cosine x is sine x plus c. That's simple. So how can you remember this? Remember what are the derivatives? The derivative of cosine is negative sine, and the derivative of sine is cosine, positive cosine. So you have to, or you can also think of it like this: the antiderivative of cosine, if you say, is negative sine x. Now differentiate this, so you should get back that. But if you differentiate the negative sine x, you get negative cosine x, which is not what we have on the left side. So it means you have to write positive sine x. So this is how we do the integration, or the indefinite integral. Okay, now we are going to do definite. Okay, now again here, how will we solve this one? Well, if you recall, if you have, again by algebra, you have a plus b over c, you can write it as a over c plus b over c. So this is what you should do here. So you can write it as integral of u to the 1/2 over u squared minus u over u squared du, and the integral is going from 1 to 4, which is equal to, now integral from 1 to 4. Now we simplify the power. So what do I get here? I have 1/2 minus 2, which will give me negative 3/2. So I have u to the negative 3/2 minus 4. No, sorry, this was u over u square. So I have 1 over u. And then du. Okay, now I will do the antiderivative of this quantity, which is going to be u to the negative 1/2, because when you add the negative 1 to negative 3/2, so you add 1, you'll end up getting negative 1/2. So I have u to the 1/2 divided by 1/2 minus, now what is the integral of 1 over u? Ln of u. So ln of absolute value of u. And then I have 1 to 4. Apply the FTC part 2. I will plug in the limits. So this will go up. It will become 2u to the 1/2 and minus ln of u will stay like it is, and then limits are from 1 to 4 is equal to, now first I plug in the 4. So I get 2 times 4 to the 1/2. This is actually what? This is actually square root of u. So if you want, you can write here 2 times square root of 4, or you can write it as 4 to the 1/2 power minus ln of absolute value of 4. So this is the upper limit minus the lower limit. What is the lower limit? It's 1. So I get 2 times square root of 1 minus ln of absolute value of 1. Now note here, we don't need the absolute value in here, or that we plugged in. We don't need this absolute value, we don't need this, because, or you can say the absolute value of 4 is 4, so, and absolute value of 1 is 1. So applying the condition, so I get, I'll just simplify. So 2 into square root 4. Square root 4 is 2, and then we have 2 here, so we get 4 minus ln of 4. 4 minus ln of 4, and then I have minus 2, and then I have plus ln of 1. Ln of 1 is 0. So I have 4 minus 4 minus 2, which is 2, minus ln of 4. Now note here, we can simplify ln of 4 as 2 minus 2 ln of 2. Can you think why I can write this? Again, you have to recall the properties of logarithm. Next example. B is over here, so let's go down here. So I have 1 minus sine square t over sine square t. Again, remember, can we do it like integral of the top divided by integral of the bottom? No, we cannot. And also, if you notice, this will not be, if you see integral of sine square t, that is something we don't have in our table. So we need some other, and we have no, no knowledge of how to, you guys don't have the knowledge to how to do this yet. So what else can I do? Well, the stuff that we have been doing until now. Split it. So pi over 4 to pi over 2. I can write it as 1 over sine square t minus sine square t over sine square t dt, which will be equal to, so integral pi over 4 pi over 2. Now 1 over sine square t. Do we have something like that in our table? You don't see like something like that, but I am seeing this one, cosecant square x. So isn't this what we have? 1 over sine is cosecant, so 1 over sine square is cosecant square t. We have cosecant square t, and this is 1 minus 1 dt. Now it became simpler. So we can now say this is equal to the integral of cosecant square t, which is negative cosecant t. And the negative 1 will be negative t. And then the limits are from pi over 4 to pi over 2. So now I plug in the limits, first the upper limit and then minus the lower limit. So I have a negative secant pi over 2 minus pi over 2 minus negative secant pi over 4 minus pi over 4. Need more space. And move this one over here, and then I should be able to write the answer here. Yeah, so what is cosecant of pi over 2? Well, remember cosecant is 1 over sine. So if you want to know cosecant of pi over 2, you can figure out what is 1 over sine of pi over 2. Sine of pi over 2 is 1, so 1 over 1 is 1. So I get negative 1 minus pi over 2 minus negative cosecant pi over 4. Remember, it will be 1 over sine of pi over 4. What is sine of pi over 4? Root 2 over 2, or you can say just root 2. So sine of pi over 4 is equal to square root of 2 over 2. Or this is equal to, if I rationalize the numerator, multiply both top and bottom by square root of 2. Why would I do that? Because remember, we are trying to find cosecant of pi over 4, which will be 1 over sine of pi over 4. So if you do it this way, you can still get the same answer. So 1 over sine of pi over 2 will be 1 over square root of 2 over 2, which will then become 2 over square root 2, and then you can rationalize the denominator and simplify the answer. So it's your choice how you do it. Let me do it this way so you can understand what is happening. What I do here is I rationalize the numerator, because remember it's 1 over cosecant. Cosecant is 1 over sine, so square root 2 will be in the denominator. So we will have to rationalize anyway. So here I am getting 2 divided by 2 square root 2, which gives me 1 over square root 2. So now if sine of pi over 3 is 1 over square root of 2, then cosecant of pi over 4 will be square root 2 over 1 or square root 2. So negative square root of 2 minus pi over 4. So here now we can write it as negative 1 minus pi over 2 plus square root of 2 plus pi over 4. So negative 1 plus square root of 2, we can write it like this. Then now we can combine these. So this will give me negative pi over 4. That will be your answer. So one more and then I will stop. And next thing is, so here, how do we do this one now? I think we did this one in the indefinite integrals. So this is, we write it like pi over 6 to pi over 4. We distribute. So we secant of theta times tangent of theta plus secant square theta d theta, which is equal to, which gives you can now just anti-differentiate. So we get secant of theta plus tangent of theta and then limits. Plug in the limits. Secant of pi over 4 plus tangent of pi over 4. Now you should know these values. You shouldn't be plugging them in the calculator and finding, because calculator will give you decimal values which are not accurate. You should know the accurate values of these strict function. Okay, so this is one top limit minus the bottom limit. Secant of pi over 6 plus tangent of pi over 6, which is equal to, now secant of pi over 4 is same thing as what we got the secant of pi over 4 earlier. So this will be square root of 2 plus tangent of pi over 4 is 1 minus, okay, secant of pi over 6. How do we figure that out? Well, remember, sine of pi over 6 is 1/2. So cosine of pi over 6 will be square root of 3 over 2. So secant of pi over 6 will be 2 over square root of 3. Now I already wrote this, so you can easily from here figure out what is tangent of pi over 6. It will be sine over cosine, so it will be 1/2 divided by square root of 3 over 2, which makes it 1 over square root of 3. When you rationalize this one, we can write it first and then do rationalizing. So this will be negative secant of pi over 6, which is negative 2 over square root of 3, then minus 1 over square root of 3. We can combine these two. So we get square root of 2 plus 1 minus 3 over square root of 3, which actually can be simplified by rationalizing this one. So we end up getting square root of 2 plus 1 minus square root of 3. That is the answer. So this is how we do the definite integral. Let's stop now.